Okay, so on to the last one of these kind of high-level abstractions of how we can make strings inside of Odin. And again, I say kind of a high-level abstraction because if we look under the hood in the fmt.odin file, we have the bprint, which is just under the tprint procedures we looked at in the last video. And we can see again, it is essentially just a wraparound an sbprint function, which takes in a string builder and then makes our strings from us. But where does this differ from aprint and tprint? Well, bprint stands for a buffered print. That is because we need to supply the buffer, so sort of the staging area itself, for where the information of this string is going to live. Remember, a string is just a pointer to some data and the length that it's allowed to read into. When it comes to aprint and bprint, we passed in allocators, or well, we didn't need to pass in allocators. They were kind of done for us implicitly, especially with tprint, because tprint can only take in the temporary allocator, whereas up here in the aprint, if we really wanted to, we could swap this allocator around and use something else. This is not the case inside of bprint. Bprint expects us to pass in the information. Hey, this is where this information for the string is going to live. And we do that by passing in a slice, not the actual array itself, but a slice to it. This confused me when I first started programming in Odin. I saw this code right here, and I assumed, oh, that is an array of bytes. It is actually a slice of bytes, and I will demonstrate that in a second. One thing to note is, even though the procedure here says it takes in a U8, there is actually a alias to U8 called byte itself. You can see here that byte is an alias for U8 and is equivalent to U8. So if you want to be a bit more descriptive in your code, instead of using U8, you can use the word byte. They are basically the same thing, but it might make it more descriptive, like, hey, this is just an array of bytes. There's no, numerical encoding here. I just want the array of bytes. So you can use that if you want. Also, when I say that it is kind of the last high level abstractions for making simple strings inside of Odin, if you do want to start getting into the lower levels of it, where instead of using any of these bprint or sbprint procedures, and you want to start actually having more control over how your strings are created inside of the string package itself, so not the format package, but the string package, you can see here that we have the builder object. So this is what builder is. It is just a structure which is a dynamic array of unsigned integers. And then you have the procedures kind of down here where you can start making and editing the builder itself. So that's one thing I'll probably be looking into the future, how to actually use the string builder itself and not just these wrappers around it. So to give kind of an example of what's going to happen here is, first of all, we need to create some type of buffer, and this is going to live in the stack. Because aprint and tprint are dynamically allocated, they can grow and they can shrink and they can be freed up as the program continues. As this buffer is going to live on the stack, it cannot grow or shrink in size. It must be already predetermined to how big the buffer is going to be. Once we have this buffer of uninitialized memory, we can then use the bprint function to write in the buffer. And once that is done, we can, if we want, assign a string to that buffer. In other words, we have the data existing right now, and if we want to, we can get a string and we can tell it where the start of this buffer is, and it'll also have the length of the buffer that has been written into. If some of the memory is not being touched yet by the bprint, so we create a buffer of 1,000 characters, but we only write a few hundred into it, the string will only go as long as we have written into the buffer. It won't continue anywhere else. And to demonstrate that, what I mean by optionally creating a string is, if you notice, the tprint and aprint all have these tags above them, and it says required result, required result, required result, which means we need to get the string that comes back to them. We cannot call this procedure and do nothing with it. That's because this memory is dynamically allocated. And if you're losing the return from these, you're losing the string. So you're kind of losing your reference to where this memory exists inside of their heap. But because bprint takes in a slice, and this is going to exist on the stack, what we can do is we can ignore the string altogether. We don't actually need to create a string out of this. We can just use bprint if we want to write in this information to the buffer itself. So over here, I have a quick example, and we have the buffers. We have a big buffer of 100 bytes, and we have a small buffer of 10 bytes. And then just printing out the buffer to show that these are all 0, they initialize to 0, there's nothing actually written to them yet. And then down here, we're calling the bprint function, or the bprint procedure. And just like aprint, tprint, regular print, eprint, they all come with the same kind of naming convention where if we want a formatted string, we append an F on the end of them. And then if we want a new line on the end of that, we then do the ln, just like in all the other examples I've shown in the past. That will take in the buffer up here. So our buffer of 100 bytes. And this will be the location where all of this information here gets written to. It will be written into here, and then the end result will be the starting location. So the starting memory address of all this information will be given to the string. And then because we're writing, maybe it's about 50-ish characters here, the string will be told that you start here and then you should read about 50 characters into this byte, or 50 runes in this case, as Odin works on runes in Unicode, not ASCII. So that will then allow us to have the string and then print it out if we want. We'll also see down here that if we reprint all the information that is inside of the buffer, we can see that we've actually written to it. So I'll run this program right now. Oop, need to get out of insert mode. So Odin run dot. You can see here that we've created the buffer and the buffer is all zeroed out. Around here, we actually write into the buffer and then get our string. And our string will only go to read into the buffer as far as we have written to the buffer. Inside of the bprint procedures down there somewhere, it figures out how much we're writing into it, and then it only returns that length to the string. It doesn't try to read the entire buffer. And we reprint to the buffer down here, and this will be the numerical encoding of all this information up here. And you can see we didn't fill the buffer completely. There's still a bunch of zeros on the end, so we could have added more information to this string. Go back into the actual file. I put some to-dos for me here. So as I said before, that the word byte is essentially the exact same thing as a unsigned integer. They're just an alias to each other. So you can either have the U8 or you can use the keyword byte if you want to be more descriptive with your words. That might be better for you to read. You might like it more. That's up to you. You don't need to do that, but you can. And then another thing I mentioned is that you're not passing in the array itself. You're not passing in this object. You're passing a slice of that object into it. So if I just try to pass in buffer right now, we should get some type of error. And you can see there, yes, cannot assign buffer of type 100U8 to a U8. And again, this, when you first started programming Odin, was kind of confusing to me because I was looking at this like, well, no, it says it's an array there. So why does this array not work? That's because we are not passing in an array. We're passing in a slice to the array. So a slice, it works a lot like a string. It is essentially a pointer into memory somewhere and then a length. And this is just how these procedures work. I believe it is because of efficiency. Essentially, if we're always working with slices, all we ever need to do pass into these procedures is we just pass in the pointer to where the data starts and then the length to how much we read into it. Whereas if we were passing in the actual buffer itself, each time we call this procedure, we would need to pass in the 100 bytes of information. Or if it's a slice to anything else, if it's a slice to floating point numbers that is 1,000 long, an array of floating point numbers, which is 1,000 floats long. If we were to try and use a procedure on that array, I know Odin actually has some clever inner workings around it anyways, where it does small things with memory. Essentially what would happen, typically speaking, is we would copy that 1,000 floats into the procedure and then do our operations on it. But by passing in a slice, all we're ever passing in is two values, which is much quicker. We're passing in the starting point of the array and how full the array is, the actual length of it. How far do we go into it? So what we could do is we could say that the buffer is actually only going to start at the 5th character and go up into the 20th. And if we rerun this program right now, we can see that the string has become a lot shorter because we told the buffer that it was only going to start somewhere around here and only go up to about here. Or we told the slice to the buffer. NVM. So that is essentially how this works. Another thing I mentioned was we do not need to actually return a string. This is optional because this memory lives on the stack and the slice. There's no worry about having a dangling pointer. There's no worry about having memory leaks. This right now exists on the stack. So once this stack frame gets finished, in this case, we only have it within this one function call, procedure call, main. So at the end of the program, it gets deleted anyways. But assuming you have a bigger program with multiple procedures and you're getting stack frames up here, let's assume that our buffer lives up here. The other procedures, the aprint and the tprint, if we were to lose that stack frame but not return the string, we would lose our pointer to that memory. And if this was just used on the regular allocator, we would lose our ability to delete that memory. So we'd start getting a memory leak. But in this case, because this buffer stack, the slice to the buffer lives inside of the stack memory, once this gets deleted, removed from the stack, if we had a larger program going on, we would just free the memory up anyways. That memory would be removed and a new stack frame would be placed on top of it. Because of that, there is no actual rule that says we need to write into a string. We don't. We can, and you most likely should with this procedure, as it seems to be very much intended that you're making a string out of it. But I can just call this procedure by itself. Unlike aprint and tprint, we would get errors if we try to do this. If I call this, you will see that I need to tell it that we're making a slice again. But you will see that this program works perfectly fine. There's no string being created. The string doesn't exist, but the buffer has still been written into. And maybe you can figure out a better way. Not a better way. You can figure out some use case for this where I don't want a string. I just want the information in the buffer. I'm pretty sure we could then go on to make a file out of this information here. So you could say, well, I've got my buffer written in, so I don't need to make a string. All I want is the information put in the buffer, and then I want to save this to a file. So you could skip the step of making the string. I'm pretty sure that will work. I don't see a reason why Odin won't already have it set up to some type of procedure where it's like OS create file from buffer, create file from bytes. I'm pretty sure that will exist somewhere and you can do that. What else is there? Okay, so what happens if we don't have space in this? That is a good thing to wonder. What happens if we run out of space? So let me just decide to make a stack string again. So we have the small buffer up top, and what happens if we try to write more than 10 ruins inside of this buffer? So small buffer, I'm pretty sure we will just stop writing to it. There won't be an actual error. There's going to be some handling there that says we're overwriting this, but I don't think anything breaks. And I might want to actually run the program, not go back into the code. Undeclared stack string. I'm spelling names wrong again. String. I'm always missing letters off somewhere. String. And yeah, you can see. So if you do happen to run out of space in your buffer, it is not necessarily the end of the world for your program. It will still continue. The buffer will... Oh, I'm not printing out the proper buffer up here. Let me print out the small buffer to show you what is happening. Small data. Nope, not small data. Not there. Not there. Small buffer for the data inside of the small buffer. We'll see that the small buffer fills up, but the program does not crash. Now, this might be very bad for your program in general. You can see here the buffer is completely filled, and all we got to was this will instead of the full string like we did before. The program itself won't crash. It will continue, but the rest of that information that is being written to the buffer has been lost. It's being disappeared. Somewhere along the line, the Odin itself, the compiler, is checking, like, we're writing to this buffer, we filled it up, here's the string back, all that other information is lost. It has been taken away from you. And yeah, program won't crash, but losing information is often a bad thing. So maybe if you're relying on that full string somewhere else inside of your program, that could cause logical errors, that could cause crashes later on. But right now, with the way this works, the program will still continue. And yeah, I think that's all I have to say about the bprint. It is a way for making the strings on the stack rather than dynamically allocating them on the heap. The upside of this is it's quicker to access this memory. The downside is because it's on the stack, this memory can't grow. We must have some array already allocated somewhere, and then we pass in a slice to that array. And yeah, I think that is, yeah, I'm done. I'll see you in the next one.